Okay, last but not least, certainly not least on section 3.2, is this. Now, I've given you, up to this point, the equation. You and I have graphed it. Okay, you and I have graphed it. So what I would do at this point before we start this lesson, go back, see if you can graph the ones I graphed in the videos. Practice those. Please practice them. Okay? Now that we have tried to graph them, I've given you the equation, you've given me the graph. But now, what we're going to do is I'm going to give you the graph, and I want you to give me the equation. So it's going to say something like this. Find the equation in y equals a sine of bx that forms the following graph. So I'm going to draw this graph for you. This would be 6, negative 6, negative 2 pi, negative pi, pi, 2 pi, 3 pi, 4 pi. Okay? And here's what our graph looks like. Okay? Our graph is going to look exactly like this. Okay? There's a better picture of it in your book, page 146. That's my rendering. All right, so we're trying to find an equation in this form. So what two things do we need? We need A and we need B. So A is the amplitude. So how many units are we away from 0? Well, look at your greatest point on the graph and your lowest point on the graph. They're both 6 units away from 0. So I know my A is 6. All right, what is B? Well, what is one period of the sine graph? Remember, one period of the sine graph goes something like this. It's going to go, you're going to have basically two U's there, two curves, two big curves, in order to have a full period in the sine graph. So notice, look from 0 to 4 pi. That gives you your two big U's, your two big curves. So I know that my period here is 4 pi. Okay? Because that gives me my two big curves, which is what a sine graph is. So I know my period is 4 pi. Well, if my period is 4 pi, and I know that a period is 2 pi over b, we'll cross multiply and divide. This is 4 pi times b equals 2 pi. So if you divide by 4 pi, you get your b to be 1/2. So b is 1/2 on this particular problem. Now, the rush is for people to do this. Oh man, I have it, Mr. Francis. My answer is y equals 1/2. My answer is y equals 6 sine of 1/2 x. And they miss it. Why did they miss it there, folks? Why did they miss it? Well, look at this. This is the basic sine curve. Basic sine wave there. Okay? What do you notice about that sine wave versus the one we have up above it? Hopefully you're screaming that it's flipped. That's correct. So what do we have to have if it's flipped? We have to have a negative in front of our A value if it's flipped. Okay? a negative in front of our A value. And so this would be the answer to this problem. This is our y equals A sine bx. Y equals A sine bx. So be careful with that. Make sure you know what the originals look like so that you will be able to realize when it's flipped or not. Okay? When it's flipped or not. Any questions on that? If you have some, please email me, let me know. I said that like you're sitting here in the room with me. Tells you how long I've been teaching this stuff. All right, so last but not least is period and frequency. A lot of people ask where this is applied in an everyday situation. Well, if you were to take a tuning fork and you were to hit it and you get that vibrating sound off of a tuning fork, for those of you that are music people, the frequency of that sound is always going to be in either a sine or a cosine wave. Okay, it's always going to be that way. So basically, what we can say is this. We can say that the period is 1 over the frequency. And this is the period of time for one cycle, one complete cycle. In the same instance, we can say that the frequency is 1 over the period. And frequency here is the number of cycles per unit of time. Number of cycles per unit of time. Okay, so for instance, now this problem's at the bottom of page 147 in your book. Bottom of page 147 in your book. And so I'll refer you to your book on this one because of how it's such a long problem. It says, referring to the tuning fork in figure 9, suppose that we want to model the motion of the tip of one prong using a sine or cosine function. We will choose deviation from the rest position to the right of positive and to the left is negative. If the prong motion has a frequency of 440 hertz cycles per second and an amplitude of 0.04 centimeters and is 0.04 centimeters to the right when t is 0, find A and B so that y equals A cosine x, so that y equals A of cosine bt, excuse me, I said x, y equals A cosine bt is an approximate model for this motion. So we've got to find A, we've got to find B, and then you will be able to write your equation for this, okay? So what is A? What is A? Well, we're given the amplitude. We're told that the amplitude is 0.04, okay? Now, since we are 0.04 centimeters to the right when t is 0, A is 0.04, not negative. Since it's to the right, it's going to be a positive A, not a negative A. Since it's to the right, it's a positive A, not a negative A. So that's basically what that's meaning on the next page at the top, okay? When they designated in the problem that right is positive, left is negative, when they told you that it's 0.04 to the right, that tells us that our amplitude here is going to be positive, not negative. So we have our A. We don't have to have a negative because it's not flipped, based on what I just told you. So now we have to find B. So remember what our period is. period equals 2 pi over b. Okay, so how do we find our period? Well, we're given in this problem the frequency. The frequency was 440 hertz per second. So I can easily find my period just like so. Now, that doesn't really help me other than if you don't know where to use that. It's great that you can find the period that easily, but why do I need the period? That's the question. Well, I need the period so I can plug into this formula and find my B, because that's the goal. We're looking for B so that we can write our equation right here. Okay, so if we solve this for B, that's PB, not peanut butter, equals 2 pi. So B equals 2 pi over P. So I need to take my P and plug it in right here. So 2 pi divided by 1 over 440. So B equals 2 pi divided by 1 over 440 hertz. Okay, hertz per second, I believe is what it said in our problem. Yes, hertz per second. Divide that out, and that's going to be 880 pi. So that's our B. Our B is 880 pi. Now that you can, now that you have this situated, and we know A and we know B, we can now write our equation. So our equation is y equals 0.04 cosine of 880 pi times t. 880 pi times t. So in our problem, they asked us what if they told us that t was 0. So what if I wanted to find the y value when t is 0? You can check this very easily. Take your y value of t equals 0, plug it in. When you plug t equals 0 in, you should get this for your answer, which should check out for you. Now, we weren't asked to plug that in, but that's a way of checking it. Why is that checking it? Well, they told us in the beginning that when t is 0, we're 0.04 centimeters to the right. Well, we just proved that right there. When t is 0, we're 0.04 to the right. Just proved that. Okay, so keep that in mind. But that's the way you write the equation from period using frequency. Okay, so that's a good, very good. I don't know if you can hear that hint in my voice. That's a very good problem right there. I love frequency problems on quizzes, tests, things like that. So that's a very good application to know for this graphing section, because a lot of people fail to see how this graphing is applicable in a daily life. Well, here's how it is, because you can find a frequency wave based on this, okay? Based on the periods, the things you know about the period. Okay, so this ends section 3.2. Let me know if you have any questions. I'm here for you. Please attempt the homework. I will be sending you some extra problems to practice on graphing so that